Welcome to this explainer. Look, stepping into a Cambridge exam hall is exactly like walking onto a high-stakes trading floor. You are forced to make split-second decisions under immense pressure, and your absolute top priority must be to invest your limited time where the mark potential is the highest. Today, we are tackling a notoriously tricky unit, mastering the Cambridge IGCSE Physics Syllabus Code 0625, specifically on ultrasound. We are going to turn that exam stress into a bulletproof strategy. I want you to mentally picture a dynamic split screen right now. Imagine a ticking timer counting down, the absolute tension of sitting down for paper 4. We've got two typical students tackling the exact same past paper question on ultrasound. Let's call them Alex and Sam. Now, Alex is our classic overloader. Alex has spent hours memorizing every single raw physics fact in the textbook, but when faced with an exam prompt, completely fails to analyze the specific scenario provided. Alex practically vomits the textbook onto the page with zero actual application. On the other side, we have Sam. Sam is the rusher. Sam scans the page, sees a familiar keyword, completely panics, rushes the math, totally misses the command word requirements, and throws away easy marks. If we were to put their answers side by side right now, it would just be a sea of red pen marks. But today we are going to fix that. We are going to show you exactly how to trade those red marks for green check marks.
Okay, let's dive into this with a direct alert straight from the principal examiner reports. Listen closely to this quote. Ultrasound is one of the most misunderstood areas in physics. The classic mistake is providing generic answers. Guys, this is the ultimate context trap. Think about it from the perspective of the examiner. They sit down and read thousands upon thousands of papers where a student accurately defines ultrasound. They give the textbook definition perfectly, but they score 0 points for the rest of the 8-mark question. Why? Because they completely failed to link that definition to the specific context in the prompt. Whether the question is talking about a boat scanning the ocean floor, a medical patient getting a scan, or a steel pipe being checked for fractures, the context is king. You absolutely cannot trade on generic information in the 0625 exam. You must trade on specific, targeted application. That's the secret sauce.
So here is our structured roadmap for today's explainer. We are going to show you exactly how we build from a core theoretical foundation right up to a foolproof, stress-tested exam strategy. First up, we'll deconstruct the ultrasound trap. Then, we lock down those core principles you have to know. Third, we're unveiling the method mark strategy. This is a real game changer that shows you how to secure points even if your final calculation completely goes off the rails. Fourth, we will master calculating depth and distance using a brilliant visual memory hack. And finally, we will wrap up with the top examiner warnings to absolutely bulletproof your final exam paper.
All right, let's jump right into Section 1, the ultrasound trap. This is all about how you actually construct your answer to avoid the generic pitfalls we just talked about.
To consistently hit those top grade boundaries, you need to use the PL framework. That stands for point, evidence, explanation, link. The Cambridge syllabus explicitly states the top-performing candidates have to exhibit the ability to transfer their understanding to completely unfamiliar examination contexts. It's not just about what you know, it's about how you apply it. Let's look at two different approaches. A generic answer, the kind Alex would write, says something like, ultrasound waves bounce off things to find cracks. It's true, but it's totally generic. But a PL answer? That links directly to the specific scenario. It sounds like this. Ultrasound waves are directed into the metal pipe, and a reflection occurring before the back wall indicates an internal fracture. Boom! Point made, evidence shown, explained clearly, and linked back to the pipe. That is exactly how top students get the green check mark. If you look at Alex's paper, the answer looks full, the handwriting is neat, but it's a total illusion. When examiners look at your paper, they're scanning for assessment objectives. If you haven't linked your physics knowledge to the exact parameters of the question, you are falling straight into the trap.
Moving right along, let's transition to Section 2, Core Principles. We need to establish the exact physics fundamentals you're expected to wield in the exam.
Now, what's really interesting about this concept is how incredibly simple it is, yet it serves as the absolute theoretical baseline for so many multi-mark questions. Whether you're taking the 0625 exam or related syllabus codes like 0651, 0652, 5054, or even 9702, you have to know this cold. Ultrasound is fundamentally defined as sound with a frequency higher than 20 kilohertz. That's 20,000 hertz. This represents the upper limit of the human hearing threshold. So, if a command word simply asks you to define ultrasound, keep it simple. You do not talk about bats. You don't start explaining submarine sonar. You just state clearly, sound with a frequency higher than 20 kilohertz. That is your point in the PL framework. Once you have that locked in, then we can move to the actual applications.
So Cambridge expects candidates to know 3 specific applications inside and out. First is non-destructive testing. Think of this as finding microscopic flaws in airplane wings without actually having to break the wing apart to look inside. Second is medical scanning, like prenatal imaging. This relies on the boundaries between different tissue densities to reflect waves back to a transducer. And third is sonar, which is used for mapping the ocean floor or finding schools of fish. Now here is the crucial part. Each of these requires the exact same physics principle. You have an emitted pulse, a reflection at a boundary, and a detected echo. But remember the trap. If the question asks about medical scanning and you start writing an essay about the speed of sound in seawater, you are getting 0 marks. Context is everything. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's move into Section 3, the method mark strategy. This is the standardized sequence that practically guarantees you points, even if you make a mistake at the very end. This is where we watch the red pen marks on our rusher, Sam's paper, magically transform into green check marks. Let me let you in on a little secret. Examiners actually want to give you marks. They really do. But they can only award them for your systematic analytical process. Here is your standardized sequence to deconstruct any complex physics problem. Step 1. Identify key elements. Scan the data in the text and write it down explicitly. For example, write speed equals 1500 meters per second, time equals 0.04 seconds. Step 2. Apply relevant principles. Actually write down the formula. Distance equals speed times time. Step 3. Execute with clear working. Plug the numbers in so the examiner sees exactly what your calculator is doing. And finally, Step 4. Verify results. Take a step back and ask, does this number make real-world sense? If you calculate the depth of the ocean as 2 millimeters, you've definitely messed up your unit conversions, right? Showing this clear step-by-step working is exactly how you secure methodology marks. Even if you fumble the final calculator input under pressure, you still get the bulk of the points. And as you're laying out those steps, presentation matters immensely. Following strict conventions acts as your defensive shield in the exam hall. You absolutely must use proper headings, correct scientific terminology, appropriate formats, and clear annotation. When you're talking about waves, use words like frequency and wavelength. Do not use words like pitch and size. Stick to the proper terminology, and the examiner instantly knows you are speaking their language and that you actually understand the physics.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, we are now entering Act 4 of our strategy session, Calculating Depth and Distance. This is all about calculation mastery.
To encode these tricky ultrasound calculation concepts perfectly, we are going to use a memory hack extracted straight from top-tier educational sources. It's called the visual story method. Look, instead of just trying to memorize a dry, boring formula, you need to create a vivid mental movie of what the physics is actually doing in the real world. Let's do a quick interactive workshop right now. Imagine scanning a complex physics data table. You have a 60-second visual countdown timer in your head. You're trying to extract the core trend. When you face a flawed sample paragraph, say a student multiplies speed by the total time and claims that is the distance to the seabed, your visual story is going to act as an alarm bell in your brain telling you something is wrong.
And this brilliantly illustrates why. Let's do a speed writing challenge. You have a 30-second timer to write one perfect Peel paragraph. Visualize the sonar ping leaving the ship's hull. It travels all the way down to the dark, deep water, hits the ocean floor, and then bounces all the way back up to the receiver on the ship. The time given in the exam question is almost always the total time for this entire round trip, so if you want the depth, which is the distance just one way, you must divide the total distance or the total time by 2. If you were doing that speed writing exercise right now, your perfect Peel paragraph would explicitly state, because the time given is for the echo to return, it represents twice the distance to the seabed. Therefore, the calculated distance must be divided by 2. Writing that exact sentence proves you understand the physical reality of the scenario, and it guarantees you the final mark.
Let's move to our final segment, Section 5, Top Examiner Warnings. We're going to build your ultimate cheat sheet recap right now to get your mark potential up to 100%. Listen up, because top-scoring candidates do not just state facts, they evaluate them. When command words in the exam ask you to compare ultrasound with audible sound, or maybe compare X-rays with ultrasound in medical scanning,
Comparative analysis strictly requires identifying similarities and differences. You can't just list a bunch of stuff they have in common. You must use comparative connectives like whereas, however, or similarly. And you have to justify every single decision with evidence. You're analyzing the flaws, you're extracting the core trends, and strictly applying that analytical framework while managing your time matrix is absolutely crucial for those top grades.
To summarize our complete physics answering system, here are the top 3 mistakes extracted directly from the principal examiner reports that you must actively avoid. Number 1. Using the wrong approach for the wrong context. You have to decode the command words first. Number 2. Forgetting to check your format, presentation, and unit conversions. Always apply the method mark strategy and show you're working. And number 3. The absolute most fatal error of all. Providing generic answers that are not specific to the given context. If the exam asks about a steel beam, you talk about the steel beam.
So, I leave you with this final provocative question. Will you fall into the generic context trap, or will you use the method mark strategy and the Peel framework to secure every single point available? The choice between a sea of red pen marks and a perfect score really just comes down to how specifically you can apply these core physics principles. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.